One of the most underappreciated yet critical protective functions of adipose tissue is its ability to shield other organs from the harmful effects of lipid overload, a phenomenon known as lipotoxicity. In times of caloric excess, healthy, insulin-sensitive adipocytes act as a metabolic sink, safely absorbing surplus fatty acids and storing them as triglycerides within specialized lipid droplets. This capacity prevents excess lipids from circulating in the bloodstream or depositing in non-adipose tissues, such as the liver, heart, pancreas, and skeletal muscle, where they can wreak havoc on cellular function. In a well-functioning fat depot, adipocytes remain flexible. They can proliferate to increase the number of fat cells, hyperplasia, or expand modestly in size, hypertrophy, without triggering stress or inflammation. This ability to adapt is vital because it allows adipose tissue to buffer the body during periods of positive energy balance, like after a calorie-dense meal or prolonged overeating, while maintaining metabolic stability in other tissues. Such a protective mechanism has been described in lean, insulin-sensitive individuals who, despite moderate weight gain, maintain healthy metabolic profiles because their adipose tissue continues to sequester excess lipids effectively. Conversely, when adipose tissue becomes dysfunctional, whether due to chronic inflammation, genetic predisposition, or prolonged overnutrition, it loses its capacity to expand or recruit new adipocytes. Instead, existing fat cells become engorged to the point of cellular stress, leading to impaired insulin signaling within adipocytes themselves. This dysfunction causes lipids to spill over into the bloodstream as free fatty acids, which then infiltrate other organs. In the liver, this ectopic fat accumulation contributes to non-alcoholic fatty liver disease, NEFLD, and insulin resistance. In skeletal muscle, it disrupts glucose uptake and promotes diabetes. In the heart, it leads to lipotoxic cardiomyopathy, which impairs heart function, and in pancreatic beta cells, it can trigger apoptosis, reducing insulin secretion capacity. Elegant studies in both animal models and humans have demonstrated that simply restoring healthy, insulin-sensitive adipose tissue, even if overall fat mass remains high, can dramatically improve systemic metabolic health. For instance, transgenic mice with expanded but metabolically healthy fat depots are protected from insulin resistance and fatty liver despite obesity, while mice with limited fat storage capacity, such as lipodystrophic models, develop severe insulin resistance and diabetes even when lean because they cannot sequester circulating lipids. Similarly, human patients with congenital or acquired lipodystrophy, who lack adequate adipose tissue, suffer from extreme ectopic fat deposition and severe metabolic disease despite having very little body fat, highlighting the indispensable role of adipose tissue as a safe reservoir. Moreover, the benefits of healthy fat storage extend beyond the metabolic sphere. By preventing ectopic lipid deposition, adipose tissue reduces the burden of lipotoxic intermediates like ceramides and diacylglycerols, which trigger inflammation, oxidative stress, and mitochondrial dysfunction in peripheral organs. This protective role of adipose tissue helps maintain the structural and functional integrity of vital organs, further emphasizing that fat cells are active defenders of systemic health. Altogether, the capacity of functional adipose tissue to mop up excess lipids and keep them safely compartmentalized demonstrates that fat cells are not inherently harmful, but essential protectors of metabolic and organ health. The failure of adipose tissue to expand healthily, rather than fat mass alone, is the key driver of lipotoxicity and its cascade of metabolic diseases. Therefore, interventions that preserve or restore the health and flexibility of adipose depots hold great promise for preventing or reversing conditions like type 2 diabetes, fatty liver disease, and cardiovascular complications, further underscoring the indispensable role of adipocytes as guardians of systemic homeostasis.